Hello, so this is the setup we have for the solar panel to power the refrigerator. That's the setup. We are just using the power we get from the solar panel to power the refrigerator also. Instead of a refrigerator, since we can't actually have a full setup there, we have something called cooling pads. Let me just explain this in brief. That right there, that's the solar panel, and it has been suspended with two stepper motors, one over here, one over there, and when when kept outside, what happens is the microcontrollers here, which I'll switch on in a little while to show you how it works. Every 9 minutes or so, yeah, every 9 minutes, what happens is the stepper motor rotates 9 degrees. So basically, the starting position is, let's say, somewhat like this, and slowly it just keeps turning like this. So throughout the day, it turns completely towards that way. So basically, what it's doing is when the sun comes up in the east direction, say this is facing towards the east right now. So basically, the sun goes up all the way like this in the same fashion I'm moving my phone, and even the solar panel moves in the same way, and hence it is always facing the sun in the perpendicular direction and giving the maximum bar output. Okay, so how this microcontroller works. The solar panel, the stepper motors are all connected to this microcontroller circuit board here, and from the circuit board it tells us how much power it's getting, and how much current, and what is the battery charge. So basically, the power from the solar panel is charging the battery there, and the battery is the one which powers the main thing. So when it's not in use, say in the night time, the battery will be powering the whole circuit. In the morning, while it is powering the circuit, it is simultaneously being charged from the solar power. So that's how it gives us maximum efficiency and never runs out of power. And these two wires here, they come out of the circuit board, and here this is these are the cooling pads here. These four things, these white tiles you see here, these are the cooling pads, and basically they get cooled really cool when the circuit is switched on. And this is just to represent a refrigerator model. Instead of the setup here, we'd probably just connect a refrigerator and keep things inside cool. That's the basic idea. Let me just go ahead and switch this on here, and you'll be able to notice it when probably will be able to notice it when I switch it on here. The thing slightly moves. You can see how it moves. Just a demonstration. Keep looking at the solar panel here. So if you can notice that it slightly moved, that's 9 degrees. And in the morning, every morning, it starts this cycle, and by the end of the day, it would have completely rotated to the side. So it always keeps in track of the sun. And like I said here, it this here, just let me focus there. Like it's showing us, since it's inside, we're not having a lot of power there. It even indicates the temperature, the current from the solar cell, the voltage from the solar cell. That is what it's indicating right there, along with the time, at what time it started, and things like that. So that's the whole setup. This is just something where we can probably, instead of the battery there, we can power it up, directly plug it into the power socket, and it's the same thing. It's the same, basically the same idea. Instead of the battery, we'll be using a power outlet. And every 9 minutes, say if we waited for another 9 minutes, it would again rotate another 9 degrees. And that's the whole basic idea. So in the morning the sun is like this, and by the end of the day it's moving like this, the way I'm moving my camera, and even the solar panel does the same. From the studies we did, when the battery solar panel is perpendicular to the sunlight, we get maximum energy, and hence the efficiency is also increased. Well, the battery and the microcontroller and everything else is the same. We usually see that everywhere, but what's innovative, what's different, is the way the solar panel moves. It is cost effective too. It doesn't cost too much, just two stepper motors in this, but it greatly increases the efficiency. So that's something to think about. And an application is a portable refrigerator. We're not talking about really big refrigerators because they require a lot of wattage, but small something like Chota Cool. There's a small portable refrigerator which is being used nowadays, which can be taken around, which and it also requires less power to operate. So those are the kind of refrigerators and other things which we can use, which can be used for this as an application. All in all, the efficiency is increased, but we are not spending too much money, too much extra money. It's just a matter of that setup right there, and the whole efficiency is increased manyfold. It's very worth it. Thank you for the demonstration. Thank you for letting me demonstrate the project, and yeah, that's it. Thank you.